Inside the CPU, speed is not enough, and precision is not enough. To stay fast, the CPU must think ahead. It must act before it knows, guess before it sees, and move before it understands. This is out-of-order execution, a hidden intelligence and a silent strategy that keeps the CPU busy every moment. Today, you enter a world where instructions break the rules, where order is an illusion, and where the CPU runs ahead of time. Programs look simple, one instruction after another, a clean and predictable sequence. But inside the CPU, this order becomes a problem. Some instructions depend on others. You cannot add until you load, you cannot compare until you compute, and you cannot jump until you decide. If the CPU waited for each instruction to finish before starting the next, it would be very slow. Waiting is the enemy. So engineers found a way to break the line and let the CPU work ahead, even when the program says otherwise. This is why out-of-order execution exists. The CPU does not look at one instruction, it looks at many. A window, a batch of upcoming commands, fetched, decoded, and waiting. Inside this window, the CPU searches for opportunities, which instructions are ready, which ones have their data, and which ones can run right now. The window is the stage, and the CPU is the director, choosing, rearranging, and scheduling based on readiness, not order. This is the first step toward thinking ahead. Once instructions enter the window, they move into reservation stations, tiny holding areas where they wait for their moment. Each station tracks what the instruction needs: inputs, registers, and data. If something is missing, the instruction waits. If everything is ready, it fires. Reservation stations are the waiting rooms of the CPU, but unlike humans, the CPU does not wait patiently. It watches constantly, and the moment an input arrives, the instruction is released. This is how the CPU stays busy, always ready, and always watching. Out-of-order execution creates a problem. If instructions finish in a different order than they started, how do we keep the program correct? The answer is the Reorder Buffer, a structure that tracks every instruction from start to finish. It ensures that results are written back in the correct order, even if they were executed out of order. The Reorder Buffer is the guardian of correctness, preserving the illusion that everything happened in sequence, even when it did not. Registers are limited, and programs reuse them constantly, creating false dependencies, two instructions using the same register even when they do not depend on each other. To solve this, the CPU renames registers, mapping logical registers to physical ones. This creates more space, more freedom, and more parallelism. Register renaming breaks false chains, removes fake dependencies, and unlocks hidden performance. It is one of the most powerful techniques in modern CPUs, a trick that turns limitation into opportunity. Modern CPUs do not have one engine, they have many: arithmetic units, logic units, load units, store units, and floating point units. Each one is a specialist. Out-of-order execution keeps them fed constantly. If one unit is busy, another can take over. If one instruction waits, another can run. This is parallelism inside a single core, a dance of independent engines working at once. The CPU is not one worker, it is a team. Sometimes the CPU does not know what will happen next: a branch, a decision, a fork. But waiting is too slow, so the CPU speculates. It predicts the future and executes instructions before knowing if the prediction is correct. If it guessed right, the work was useful. If it guessed wrong, the work is discarded. Speculation is risk and reward, a gamble that pays off most of the time. This is how the CPU stays fast, even when the future is uncertain. You have seen the hidden intelligence inside the CPU, the window, the stations, the buffers, the renaming, and the speculation. All of them work together to break the rules of order and keep the CPU busy every moment. Out-of-order execution is not chaos. It is strategy, precision, and elegance. In the next episode, you explore the future: chiplets, 3D stacking, new architectures, and new horizons. The journey continues until the next instruction. Thanks for watching, and I'll see you in the next chapter of this digital adventure.